Hello viewers, in this video we'll solve these problems. So question number one, you have A to be given as this, and we have also B, so we want to find the sum of A, B and A. So let's start with A. These questions are from logarithm and exponential equations, as well as some questions from circular motion. So 2 log 8 of 125. So here we just use the laws of logarithm. We can write this as log to base 2 to power 3. And 125, we can write it as 5 to power 3. Now this is going to be 2. This is 2 to power 3. So it will be 1 over 3 log of 2, 5 over 3. Remember, if we have log to base ak, a to power k of x, is nothing as 1 over k log of a of x. So that is what we used here, because this is 2 to power 3, and the 3 will go down, 1 over 3 will go down. So that's it. Now we can write this as 2. This is 1 over 3. 1 over 3, this 3 can also come down. So we have, it will just be 3 divided by 3 log of 2 of 5. So what have we used again? We've used that if you have log x to n, you can bring your n down. So you have n log x. So here is to base 2. So here we will just be 2. 3 divided by 3 is 1. So you just have log to base 2 of 5. And this is nothing but what? This is nothing but 5. So which property have we used? We have used the fact that if you have a log to base a of x is just equals to x. All right, so in solving this problem, we have used how many laws? We've used the fact that if you have log to base ak of x is 1 over k log of ax. And we've also used that if you have log to base a of x to power n is nothing but n log ax. And we've also used that if you have a log to base a of x is equals to x. Okay. Now, let's go to the second part. So the second part is this. B, we can write B as log to power 2 over 2, 3 to power 2 times log to base 3 of, this is 8. We can write it as 8 and a half, 8 to power half. So the same law, this will come here as 1 divided by half, which is going to be 2 log 2, 3 square, multiply. This is going to be what? We can write this half can come down as well. So you just have half log to base 3. And you can write the 8 as 2 to power 3. So bringing this 2 down, this will become 4 log to base 2 of 3. Multiply. This 3 will come here. So you have 3 by 2 log of 3, 2. And this multiplication, you see that this is 4 times what? 3 divided by 2, which is just going to be 12 divided by 2. But here we have log 2, 3 multiplied by log to base 3 of 2. And you can see that this one, we know that anytime you have log to base what? Log to base 2 of 3 is the same thing as 1 over log to base 3 of 2. You just flip, right? So it means that this divided by this is just going to be 6. So this one, I can write it as 1 log to base 3 of 2 times 3 of 2. So this and this will cancel. So our b is nothing but 6. Hence, to answer this question, b plus a is just going to be b is 6 and a is 5. So the answer is 11. Now, question 2. Question 2, it's an exponential equation. And here we can easily write it as, take this to the other side. And now what can we see? We can see that the bases are not the same. So we can take log to base 10 or log or ling. Log to base 10 is fine. This is a common base. So here you bring x minus 1 down so that you have log 5. And here x plus 1 so that we have log 2. Now if you expand this, you have x log 5 minus log 5 is going to be x log 2 plus log 2. And we can put the x together. So you have x log 5 minus x log 2 is equals to log 2 plus log 5. And we can take x as a common factor. So we have log 5 minus log 2. It's equals to log 2 plus log 5. So what is x? X is going to be log 2 plus log 5 divided by log 5 minus log 2. And this we can further write as log of what? We can change multiplication, addition to multiplication using the laws of logarithm, and we can change subtraction to division. Okay, so now we have log to base 10, because here we're taking log to base 10. So even without any base, it means we're in base 10. And if you look at this from the change of base formula, this is just going to be log to base what? 5 over 2 of what? Of 10, which we can leave it like this, so it's fine. All right, so the next question, it's a logarithmic equation. Now, for this logarithmic equation, what do we do? If you look at this one here, this is 1 over, so this you can write it as log. Now 7 now can become the base, then here becomes this one. So what have we used? We've used the fact that anytime you have log to a to b, if you want to change the base, it's just the reciprocal of ba. So we have this part, then you can just change it to this part by interchanging the base and the exponent. So here, this is minus 2. This one we can rewrite it as log. This is 1 over 49, which we can write as what? 7 to power minus 2. And here we still have x plus 1 is equals to, this is actually 0. Why is it 0? Because we know that log to base a of 1, no matter what is the base, is just going to be what? Just going to be 0. So here you can see it's log to base 7. So a is 7, a root 7. So of 1 is 0. So this is just going to be, so what we have left here, here also you just need to flip it. So this becomes log of what? 7 to x minus 1. Okay, and here this will be log of 7 x minus 1. And here, because this is minus 2, you take the reciprocal, because it's negative, here becomes plus, so you'll have 2 times what? Half log of 7 x plus 1, it's equals to log of 7 to x minus 1. And so this 2 will go with this 2. So we have log of 7 x minus 1 plus log of 7 x plus 1. It's equals to this one. Now we can write this as multiplication since the bases are the same. So you just have x minus 1, x plus 1. And the other side you have log to base 7 of 2x minus 1. Now both sides have the same base. Here we just change addition to multiplication. Both sides have log 7, log 7. We can drop the log and just go with x minus 1 and x plus 1 equals to 2x minus 1. Okay, and if you expand this is nothing but x squared minus what? Minus 1, and this is equals to 2x minus 1. So minus 1 will go with minus 1, and you can bring x squared to this side. So we have this is equals to 0. And here we can factorize. So you have x equals to this. So it means x is equals to 0, or x is equals to what? 2. But this is a logarithmic equation. We need to always check, because remember we have some conditions that has to be met. For example, if you take x equals to 0, put x equals to 0 into the first term here. Look at this first term. After flipping, it became this one. Yeah. So if you put x equals to 0, what are you going to have? You're going to have log to base 7 of 0 minus 1. So which is log to base 7 of minus 1, which is impossible. We cannot take the logarithm of negative number. So it means you have to what? You have to reject this one. So, but I think 2 will be fine. If you put 2, it's going to be minus 2 minus 1 is 1. If you put 2 here, 2 plus 1 is 3. If you put 2 here, you have 4 minus 1, which is 3. So the only solution is just going to be 2. So the question says find the product of the solution. So the product is nothing but what? X equals to 2, because you have only one solution. Okay. All right. So now let's move to the next, the number 4. Number 4 has two parts. We have, let me see. So what do we have? Okay. So we have a potter's wheel with radius what? 8. So our radius is just what? The radius is just 8 inches. And anytime you see revolution per minute, it simply means you're looking at what? Omega, angular speed, is rev per what? Per minute. So the question asks us to find the angular speed in what? Of the wheel in rad per what? Rad per second. So this is all you need to do is just to do conversion. So what we have is this omega, it's what? It's 150 rev per what? Minute. So we need to be able to convert revolution to radian. And we know that what? We know this. We know that one revolution is 2 pi rad, right? So I just need to multiply this by what? 2 pi rad over what? Over 1 rev. Okay. So then if you look at the minute is per minute. So since you have per minute here, and we know that what? 60 seconds make 1 minute. So it means I have to multiply here 1 minute will give me what? 60 what? 60 seconds, because we want second in the denominator. So if you look at this carefully, you see that rev will cancel what? Rev. And this minute will cancel this minute. So we are left with what? 150 times what? Times 2 pi, which is going to be 300 pi rad. Then over what? 60 seconds. If you put everything, you divide, this is just going to be 5 pi rad per what? Second. Then to answer the B part say we should find the what? The linear speed on the rim of the wheel in what? In feet per what? Feet per second. So here we need it in feet per second. But what do we know? We know that linear speed is the same thing as r times what? The angular speed, where r is the radius, right? Okay. But now we know that our radius, the radius given to us is what? Is 8 inches. So now you need to be able to convert these 8 inches, you need to convert it to what? To feet. And if you look here, we are already given a conversion factor. We're given a conversion factor. So it means you have to multiply. You can see this one like 8 feet per rad if you like. You can view it that way. This you have to multiply by what? Because we know that 1 foot is equivalent to what? 12 inches, right? Then we now have to multiply by what? Our omega, which is our angular speed, which we already have, is already 5 pi rad per what? Per second. So here, all we need to do is to convert just the inches because you need the answer in feet. In feet, so you just need to convert inches to what? To feet using this conversion factor. 12 inches is equals to 1 foot. So that is why we multiply by 1 over 12. Now, this is second, right? So if you look at this, these inches will go with these inches. And here, we're going to have 8 times 5. So this will be 40 pi. Then divide by what? By 12 seconds. So here, what we have is just 12 pi feet, because this rad here will cancel this rad as well. So we were going to have 10 pi over 3 feet per what? Per second. And that is the end of this solution to this quiz. I hope it is clear. If you have any question, just feel free to ask. Thank you for watching.